Today, I will give an overview of the air quality in the most highly polluted mega city in Southeast Asia, Dhaka, Bangladesh. Dr. Pallavi already mentioned, I'm working as a professor in the Department of Chemistry, University of Dhaka, Bangladesh. And I am also working as a co-chair of the International Global Atmospheric Chemistry. And she also mentioned many of our collaborators' names. So this presentation, you will see many contributors already named at the below. So first, I will talk about the history of air pollution. You see, if you look 1940, like 80 years back, there was a air pollution, but not our reason. It was this like today we call developed nation, like United States. You see, 1940, smoke is severe in Los Angeles. And 1947, Los Angeles Air Pollution Control District forms. So in 1940 to 1950 and onward, the pollution was in the developed country. If you see 1952, air pollution disaster in London, you may heard about the haze in London. Many people are died and also many people are sick during that times. And within 10 years and so they took different steps to control air pollution. And, and after that, they started getting low air pollution exposure. But still now they have air pollution, but that is really, really low compared to the part of the world we are living. You see, if you see the picture in this book, 1940, the haze exactly you see nowadays we are seeing in IJP region during winter time. And Great London Smoke, 1952, you see there is hardly anything you can see. And it was a huge news in the media. And even in Japan, in 1950 to 1960, that time, they have very, very air pollution, high air pollution. In bottom left-hand side, you see like sky is red and cloud is red. So that was that time in 1960. And now the change of air quality, they took many steps and they are able to control air pollution. So air pollution is like not a new things or recent things is happening like last 80 years in different parts of the world. And what is the recent global status of air quality? You see, yesterday there was a report from State of Global Air 2024. Air pollution is the #2 risk factor for human death globally. And 8.1 million people dead in 2021 in the world. And air pollution now is #2 global risk factor for death for children under 5 years old. And the #1 is the malnutrition. So air pollution is the #2. And as many as 70% of these deaths to children under 5 years old come from exposure to household air pollution in Africa and Asia, typically from burning solid fuels for cooking. Basically, indoor air pollution is severely affected. And good news is, since 2000, there has been a 36% drop in household air pollution deaths globally. So it's a global scenario. Maybe the scenario is different in our part. And right-hand side picture, you can see the summary of the current global air came out exactly yesterday in the media. So, and if you see this picture, left-hand side, there are top 10 countries like Bangladesh, Chad, Pakistan, Kazakhstan, India, Oman, Bahrain, Iraq, Nepal. These are the top 10 countries of the world who exceeding the PM 2.5 guideline value given by WHO. And top 4 countries are from our region, IGP, Indo-Gangetic Plain. If you see in the picture, you can see this is really accidents is like 7 to 10 times in these 4 countries. So air pollution is a severe in our region like IJP, Indo-Gangetic Plains. And air pollution has many impacts. If you see the human health impact and climate change and agriculture, global warming, sea level rise, visibility reduction, ecosystem, air pollution is the number two for human death. You see, right inside the top figure, blood pressure and air pollution, tobacco, dietary risks, high glucose, especially diabetes, high body mass index, high LDL cholesterol, kidney dysfunction, child and malnutrition, high and low temperature. So these are the causes for high air pollution. And climate change, another serious issue globally. And air pollution in the atmosphere, and some of the chemical substances are responsible for the high temperature. And high temperature, they are absorbing the ray coming from sun and become heated our earth surface. And ozone, particulate matter, carbon dioxide, and CFC, these are the things, methane gas and water vapor, these are the things that warms us our Earth's surface, and that also change the climate. And also when climate change happening, high temperature is coming, then ozone production is giving high. So it's like opposite of climate change happening a lot of things, and also pollution. It's like pollution makes climate change, and climate change make more pollution. So this is happening here. And our country, part of this world is mainly dependent on agriculture. Our economy changing from agriculture to industry, and agriculture has a lot of impact from air pollution, especially particulate matter and ozone. In some cases, they reduce the air production. And global warming, I already mentioned, and sea level rise and visibility reduction, especially in winter time. This is happening, and many accidents also happening due to the visibility reduction. And ecosystem, you see, there are many plant and trees and biological things in the Earth system is also affected due to the air pollution. And atmospheric chemistry also changed due to the air pollutions. However, if you see the position of Bangladesh, the total human death in a year due to the environmental problems, Bangladesh with other 9 countries, top 9 countries with United States and United Kingdom. And Bangladesh is the #1 country, and 26% of the total death are due to the environmental pollution in Bangladesh. And this 26%, 70%, 75% of this 26% are due to the air pollution. And increase in premature death in many cities of the world. Dhaka is the #1 with our neighboring countries, many cities from our neighboring countries like Mumbai, Bangalore, Kolkata, Hyderabad, Chennai, Pune, Ahmedabad. So this is one of the impact aspect for air pollution in Dhaka. And you see, this is the reason why these people are dead due to the environmental and also air pollution. And this figure shows, you see, the populations, how people are impacted. The bottom one is China, then India, and in Bangladesh, you see. Bangladesh is compared to China and India, the population is much smaller, but as a population density is really, really high. And there is a 3 interim guide target for WHO. And Bangladesh, the average PM 2.5 is way ahead of the interim guideline value. They give us 35 microgram per meter cube, but on average, in Bangladesh, still now it's like 80 microgram per meter cube PM 2.5. So Bangladesh is a small country, but if you consider the population density, the impact of human health or population is way higher than two populated countries in the world like India and China. However, this air pollution also severely affected the school children. Now we have a study at 10 different schools in Dhaka city. You see, their lung function is highly compromised with the air pollution. And where the PM 2.5 concentration is higher and their lung function is more affected. And about 50 to 60% children in the school, their lung is compromised due to the air pollution. So you see, Dhaka is not like that. It was like this picture. It is like 120 years back. Deers are there. There are a lot of trees, so they are moving freely. But now Dhaka has changed a lot, like building and building everywhere. So this makes the more, these are causes for the air pollution. Nowadays, you see every day in the newspaper, this kind of news came. Dhaka air quality worsen again. Dhaka most polluted city in the world. Dhaka air quality remains unhealthy. This kind of news are coming in the newspaper. So, what are the causes for air pollution in Dhaka? If you see, if we consider in two ways, one is the major activities, another one is the energy based. If we see major activities are the mobile sources, and road dust and construction and industry dust and industrial emission and waste burning and cooking, and also most importantly transboundary air pollution are the major causes of air pollution. If you consider energy based, I think it's more or less similar with many countries in the world, like liquid fossil fuel combustion, biomass burning, both regional and local, and also coal combustion in many industries nowadays. So the figure, you can see how severe the air pollution in many parts in Bangladesh. And you see the one important pollution coming for the traffic vehicle. And we have huge traffic jam. The bottom picture, you can see a lot of traffic, stagnant in the streets. So then government made two-straight road, and still bottom and top both are stuck in the traffic jam. So this is the situation, and Dhaka became the first, I think, for the worst traffic jam in the world in 2019. And government also took many potential solutions, like 20 years old vehicles ban, leaded gasoline, making law for using low sulfur content fuel, improvement of traffic signal, ban of truck and heavy duty vehicle during daytime, change of holidays for shopping mall, change of routes of different bus lines. So it may help the reduce air pollution little bit, but still we need very aggressive action to reduce air pollution. And this is another source, indoor cooking. You also see this is this global problem, not only in Bangladesh, indoor cooking. And a top figure, the mom is cooking, and her kids also there. So this kids is really affected this air pollution. The potential solution may be improved cooking stoves. We have about 10 lakhs improved cooking stove in Bangladesh. So that make clean inside the kitchen, but the pollution comes to the outside environment. So as a very close proximity of the kitchen, it saves mom and also her kids, but it's contribute to the global pollution. But it's also one kind of solution in some parts of the world. We have about 10 lakhs improved cooking stoves, but I think that's not enough yet. And this is another garbage burning emissions. Some places in Dhaka, you'll see many people always burn their wastage, especially in winter time. They collect all the leaves and they burn it. And even we have 2 or 3 big dumping places, and there you always see there are some burning. So that has huge contribution to the worst air pollution. And there is a paper from ERI on Nepal and India, and they showed 25% total PM 2.5 are coming from garbage burning emission. If you see the left-hand side figure and this red mark, is mostly covered IJP and also Bangladesh and also Sri Lanka. So this whole part is poorly affected due to the garbage burning emission. And this is another source of air pollution, road dust, construction dust. Every year there is some road cutting for their daily work, like telephone cable, internet cable, gas line, water line. But one agency today is complete their work, maybe after 2 months another agency came and they again do the same things. So it's also have severe impact on air pollution and also public nuisance, because all the times they're cutting and people are there, they're going office and daily activities, they have to face this situation. So this is a poor coordination or collaboration among different agencies of the government. But for that reason, you will see a lot of pollution or dust in the city. And most important one is the brick kilns emission. In Bangladesh, we have about 12,000 brick kilns all over the country. And in and around Dhaka city, we have about 1,000 brick kilns. And they have many different technology, like FCK, fixed chimney kilns. And modern one is like zigzag, tunnel kilns, hybrid Hopman. So different types of kilns are there. And they use mostly coal, and coal has high sulfur and also mercury as a byproduct. So our government made some rules, like the chimney should not be less than 120 feet. And we are all FCK banned and have to transfer FCK to zigzag and maybe tunnel kings. So no soil cutting or agriculture or land used for brick kilns, and no brick kilns by residential location, and also looking for alternative materials for construction, like 2025 government has some rules. Okay, some percentage of construction materials should be taken from another alternative source, not from the bricks. So these are the potential solution, and also brick kilns is a serious issues for the air quality in Dhaka. And several years back, we have a study on different brick kilns in Dhaka. You see, in the city, all the red mark in the map is the brick kilns locations. And we went 18 brick kilns, 3 different categories, and we measured their emission from the stack. And we found zigzag is the highly polluting one. Then, FCK is the highly polluting one. Then zigzag, then Hopman. And their vicinity environment also we found the similar for other parameters. So relatively, Hopman hybrid kiln is cleaner one, but still it also produce pollution. But compared to zigzag and FCK, it's a relatively clean one. So maybe transferring from zigzag or FCK to Hopman is an short-term solution for brick kiln emission. And this is one of the important source for Dhaka air pollution. If you see the left-hand side figure, there are 4 figures, 4 seasons. And air is coming in Dhaka mostly from 2 directions. One is the IGP, another one is the from Bay of Bengal. So when air coming from IGP region, it brings a lot of haze from Indo-Gangetic Plain to the Bay of Bengal over Bangladesh. And at that time, the particulate matter goes up to 500 microgram. And WHO guideline value is annual average is 5 microgram per meter cube. So it's like 100 times higher in winter. So this is another important source for air pollution in Bangladesh as well as in Dhaka city. And for right-hand side, you will see the satellite picture of on Dhaka, how the haze is coming from IGP region to Bangladesh. And another important scenarios in Dhaka, if you see, the nighttime pollution is much higher than daytime pollution. If you see 3 filter here, one is the blank one, and one is nighttime, one is the daytime. And nighttime is more darker because nighttime pollution is much higher. This is not the one way. We have different other studies also we saw nighttime pollution is much higher than daytime. And why this is happening? This figure can explain you the boundary layer height. During daytime, you see from 10 to 4:30, the PM2.5 concentration is lower than nighttime, evening, and also whole night. And right hand side, you see the boundary layer height. During nighttime, boundary layer height is almost 1 to 5, and very low. Sometimes it's 0. But from 10 to 4:30, the boundary layer goes up to 100 meter. That means like 1 kilometer. So when pollution comes, when daytime pollution comes and it goes up. So we saw a lower pollution during daytime in the ground. And nighttime, whatever the emit, just stay there. On top of that, there are another source. Heavy duty vehicles are not operating during daytime in the city, and they are operating in the nighttime. So boundary layer and also heavy duty vehicle emission. And there are some other industries also operating only nighttime. That's an illegal industry. That contribute severe pollution during nighttime. And this picture shows how, the temperature and also relative humidity play an important role as a textbook knowledge. From industries like coal combustion, sulfur dioxide emit, and agriculture ammonia emit, and fossil fuel burning that produce nitric oxide. And they come in the atmosphere, and there is oxidation happening. They convert to higher number of oxygen, like NO2, NO2, and ammonia to ammonium, and sulfur dioxide to sulfur trioxide. And finally, they get moisture from the atmosphere, and they form bisulfate, ammonium nitrate, and they interact with each other. They produce finally ammonium sulfate, ammonium bisulfate, ammonium nitrate. So what's happening actually here? When they emit their gas, but with atmospheric conversion or interaction, they produce particles like ammonium sulfate, ammonium nitrate. When the temperature rises, they again comes to the gas phase. So there is also an atmospheric chemistry depend on the relative humidity and temperature, and also emission sources. And for measuring or for understanding the air quality in a region, we need different kind of approach, not only ground-based measurement, and not only air-based segment and space-based measurement. So we need to understand in three level of measurement. We need to measure in the ground base, and also in the aircraft, and also the space. From space, we cannot see what is happening in the ground, and from ground, we cannot see what is happening in the space. So for fully understanding the air pollution or air quality status of a city or a location, we need to combine three different ways of measuring. However, recently we also installed a low-cost sensor network in Dhaka. Not only in Dhaka, whole IGP region, Indo-Gangetic plain. You can see it started from Pakistan, India, Nepal, Bhutan, Bangladesh, Sri Lanka, and Maldives. About 300 TSI sensor installed in these countries. And in Bangladesh, we also covered 7 or 8 locations like Dinajpur, Rajshahi, Dhaka, and Netrokona, Sylhet, Bhola, and Coxbazar. And if we look in Dhaka city, we also install about 40 sensors covering all the consequences and sources of Dhaka city. And what we are getting here, we also see the strong seasonal, it's like 1 year data, and strong seasonal variation, and very high level, like about 450 microgram of PM2.5 during winter time, and monsoon time is relatively less, but still is much higher than WHO guideline value. And this is from these sites, different sites of Dhaka city. So we also see the similar pattern in our neighboring city like Kolkata. From 2013 to 2021, and we took the data is 7 days running average of PM2.5 concentration, and both cities, Dhaka and Kolkata, we strongly see a strong seasonal variation. Summer is always monsoon time is always lower and winter time is always higher. And it's really same sequence every year for the last 10 years. Even if we consider in the monthly variation, you can see the winter, January, February, and December is high concentration, and monsoon time, July, August, June, July, August is relatively low concentration. And pre-monsoon and post-monsoon time are in between. It's like it's strong seasonal as well as strong monthly variation of PM 2.5 in Dhaka, Bangladesh. And we also see the AOD, aerosol optical depth, from our AeroNet measurement. We also see the similar pattern for two locations. One is the left-hand side is Dhaka and right-hand side is Bhola. One is the urban location and one is the rural location. And AeroNet, aerosol optical depth measurement network from NASA. So they have a 1,000 station, about 1,000 all over the country. So we have two in Dhaka. We also see the similar pattern from our AOD measurement, but satellite measurement shows different, maybe not strong variation, the yellow one in the bottom. My point is here, we have strong seasonal variation and monthly variation, and it's happening every year. And not only for PM 2.5 and AOD, if we look the gaseous pollution like sulfur dioxide, nitrogen dioxide, carbon monoxide, and also the last 12 years, we see it's gradually increasing. For example, in sulfur dioxide, if you see on the top panel, it's gradually increasing from 2003 to 2019. And this sulfur dioxide also has a strong monthly variation, right hand side top figure. And nitrogen dioxide is also has a strong increasing tendency with a strong monthly variation. But ozone has different issue. It looks like it's more or less same. And also monthly variation is not like other three, CO, nitrogen dioxide, or sulfur dioxide. And carbon monoxide also shows the similar pattern like nitrogen dioxide and sulfur dioxide. So, however, what is going on? Both particulate matter and gaseous pollution in Dhaka, it shows growing tendency, increasing tendency. Just like every year, we have about 2,000 cars are introduced in the city, and traffic jam increasing. And sulfur dioxide and nitrogen dioxide are the from fossil fuel. So the amount of increasing fossil fuel, that's also contribute to this gaseous pollution in the atmosphere. And sulfur dioxide is also incomplete conversion of fossil CO. Carbon monoxide is also incomplete conversion of the fossil fuel. That's also increasing day by day in Dhaka city. So what are the chemical composition of the particulate matter? If we see black carbon, elemental carbon, organic carbon, brown carbon, these are the main constituent, and also very many individual organics like polyaromatic hydrocarbon, PFAS, POFs, and water-soluble ions like sulfate, nitrates, ammonium, and trace metal and toxic metal, and also soil dust and others. These are the major chemical constituents in particulate matter in Dhaka. You see the mostly about 70%, if we consider the total suspended particulate matter, 76% is dust particles, and rest are like elemental carbon, organic matter, water-soluble ions, and definitely trace metals. So these are the overall chemical composition of total suspended particulate matter in Dhaka city. And heavy toxic trace metal is also another important parameter in the atmosphere that has severe human health impact. If we see, this is like many cities of the world. We have a network, Spartan network, and recently published a paper, and that shows the most of the pollutant, I mean toxic and elemental carbon elements composition is way higher than other cities of the world. And especially if you see the lead pollution is like 1100 nanogram per meter cube in Dhaka. It was like 463 nanogram per meter cube in 1996, and then later gasoline was banned. So then it reduced to 70 nanogram per meter cube. Now it's again very high. And not only lead, there are some other chemical component also. If you see copper is 29 in Dhaka, one of the highest, and also zinc. And if you see arsenic, but our neighbor kind of cities like Kanpur also elevated concentration, but some cases they are mostly they are lower than Dhaka. So other part, if you consider other cities of the world, Dhaka is one of the highest concentration for trace metal, especially lead, arsenic, and copper, zinc, this metal. So it's also another scenario, toxic metal concentration in Dhaka city. And if you see plastic burning is also another recent issues, and many garbage waste burning, that's also include plastic burning. And we try to study on the plastic burning emission in one of our study in Dhaka and in Bangladesh and Nepal and in United States. And 135 triphenyl benzene is one of the big pressure for plastic burning emission, pressure for plastic burning emission. And we see the 135 triphenyl benzene tracer is way higher in Dhaka compared to other cities of the world. This is if you see Nepal, two cities is three cities in Nepal, but three locations in Nepal, and 7 locations in United States. Many of the United States locations, there is hardly any concentration, but Nepal and 1 or 2 locations in United States, they are slightly available, but Dhaka is like 10 times higher compared to other cities. But as in rural location in Bangladesh is Bola, but it has no 135 triphenyl benzene. So that means that in Dhaka, there is a lot of plastic burning happening compared to the rural Bangladesh. And it's one of the highest among our measuring locations in the world. So plastic burning is another serious issue, and also microplastic is also another issue, should be another issue for Dhaka, Bangladesh. So next couple of slides, I will talk on the source apportionment study. You all know the source apportionment study basically first collect sample on filters, then chemical composition, and analyze for chemical composition, and use different models based on USA, like CMB model or PMF model. So by using this model, we can estimate, or we can gauge what are the sources for PM 2.5. So use this study for several of our manuscripts. I'll share in next couple of slides. And you see, so one of the source apportionment study, and we found these are the major sources for air pollution in Bangladesh, like vehicular emission, construction activities, road dust, indoor cooking, brick kilns emission, garbage burning, transboundary pollution, and other industrial sources. And at the beginning, we show some slides that we also thinking these are the pollution. Now, with source apportionment study, we confirm them. Definitely, these are the sources of air pollution for PM 2.5 in Dhaka. And we also did the similar studies for gaseous pollution and also PM 2.5 and PM 10. And we also see 4 major factors for PM pollution and also gaseous pollution, like traffic emission, dust and construction activities, biomass and fossil fuel, and industrial emissions. So these are the major sources for air pollution in Bangladesh for both particulate matter and gaseous pollution, what we show at the beginning. And this is another interesting study we did during one of our strike times, and we see for black carbon concentration, we do isotopic measurement, carbon 13 and carbon 14, and we try to use them for source apportionment study, and we found 3 major sources for black carbon. One is the biomass burning, traffic emission, and coal burning. And during the normal time, biomass and traffic is like almost very close, like 44 and 50 percent, and 7% is the coal combustion. But there was a lockdown, there was hardly any traffic in the street. That time we saw biomass is much way higher than traffic emission. 63% is the biomass contribution, and 24 is the traffic emission, and 14 is the coal burning, coal combustion. So this slide indicates that if we want to any kind of mitigation option, we should not only focus on traffic emission, we have to look also for biomass burning emission. If there is no traffic or 10% or 20% traffic, then at that time biomass burning emission goes over 60%. So it's a published couple of years back in Environmental Science and Technology. And we also try to do from satellite, not satellite, aeronet AOD measurement. And we also classify the aerosol types. And we also see the anthropogenic emission, biomass burning, and mixed type at different times or different season of the year. So we did different study, like this one is the from aeronet measurement, satellite aeronet measurement. Aeronet measurement, and we also did the same thing for satellite AOD measurement, and we also did the chemical composition and PMF modeling, and we more or less we found the similar things like anthropogenic contribution and biomass contribution, burning contribution is way higher for the PM 2.5 and other gaseous pollution in Dhaka. And this is one of the important study we did by using GAIN model. And we also see almost similar result. If you see the left-hand side figure, it shows sources of variation. And right-hand side figure is the average concentration contribute from different sources. And you see the baseline is the local source, and diurnal source, and regional source, and local source, red one. And from that, we see that 25% pollution is coming from outside, and 75% pollution is from Dhaka. So for the mitigation, we need to work for the baseline and diurnal sources in Dhaka. 75% pollution. If we continue, reduce that pollution, definitely our pollution in Dhaka city will be reduced. And the final couple of slides, if you see the health impact, we took the 4 pollutant and 2 diseases, and we are trying to calculate their economic loss for per pollutant from 2019 to 2008 to 2019. This huge these 2 figures shows one is the all cases mortality associated with their pollutant, and the right-hand side is economic burden associated with the pollutant. And if we combine these 2, you can see in this figure, from 2007 to 2019, the total economic burden of due to the this pollutant and 2 diseases, and which is equivalent to our 5% GDP. I think we did this couple of years back, but last year there was another study. It's like 8% of our GDP are due to the pollution, and we consider only 4 pollutant and 2 diseases. If we consider more pollutant and more diseases, the cost will be way higher than this one. And this 5% is like 14 billion US dollar are causing for these air pollutions. So for mitigation of air pollution, at the beginning I mentioned from developed countries, they have a lot of pollution, and they took important measures so that they reduce the air pollution. And what they did actually, they did reducing toxic emission from industrial sources. So they first reduce the pollution from industrial source, and also reduce the pollution from traffic vehicles and many other engines that produce pollution. So they established emission standard and using cleaner burning gasoline, and also addressing indoor air pollution through voluntary programs. So these 3 things they did, and they get, they control their air pollution within 10 years. So something we need in our part of the world to control the air pollution. And what is the key messages from this presentation? If you see, elevated concentration of PM 2.5 in Dhaka are relatively uniform across city. So whatever the part in Dhaka, we took the pollution and we measure pollution, is the concentration is more or less same. So they have a special variation are very small, but the mixing height and time of day and seasonal leads to a large temporal variation. About 75% of the PM 2.5 is Dhaka is an urban scale problem that requires strategies that reduce pollution across the city. And 25% of PM 2.5 is associated with the regional transport into the city. And 5% of the PM 2.5 is associated with the neighborhood scale sources. Control strategies that focus on a single source of PM 2.5 are unlikely to adequate to reduce PM 2.5 concentration in Dhaka. So need develop parallel strategies to address emission from mobile source, resuspended dust, brick kilns, and other industries, open burning, and residential solid fuel combustion. So the development of sectorial strategies will be a critical part for a successful air quality management plan in Dhaka, Bangladesh. So finally, these are my collaborators from different parts of the world. And these are my group people that we are working together to get these results, and also thanks to you all and iLEAPS. So I'm happy if there is any question and comments to respond on them. Thank you, Balabi.